After 7.3 seconds of uniform acceleration from rest, so I know the initial velocity is 0 meters per second. I know time is 7.3 seconds. A spacecraft reaches an altitude of 4,800 meters up. So that's going to be my distance. So what's happening here is I have 4,800 meters, right? That's like my delta x. That's how high this rocket is going. So I have some rocket, and it's going up, and that's as high as it's going to go. Let's see. And we want to know the final velocity. So we know delta x is 4,800 meters. And I think that's enough. So we have delta x, vi, t, and v final. I don't know a here. So that's going to be delta x equals the average velocity times time. So even though I'm accelerating, I don't know what the value of acceleration is. That's why I'm going to use this equation. So we get 4,800 equals v final I'm looking for. V initial is 0 meters per second divided by 2 times time is 7.3 seconds. So it's up to you how you want to do this. I'm going to go ahead and divide both sides by 7.3 first. I personally would not split this up into 2 steps, but I know most of you do have this as a preference, so I'm just going to do this for the majority rules. So we get 657.53 equals v final plus 0 is v final, and then I'm dividing by 2. So then the next step is to multiply both sides by 2, and then my v final is going to be 1,315.1 meters per second. And for this particular one, I'm moving up. So my final velocity is going to be in the upward direction. For 5, we have a car. Its initial velocity is 24 meters per second east. It has an acceleration of 4.2 west. So I have east and I have west. So I have my car. It is initially moving east, initial velocity, 24.5 meters per second. And then the acceleration is in the opposite direction. I'm moving this way for acceleration, so it's going to be negative 4.2 meters per second squared. What's the displacement? When the velocity is 18, so final velocity is 18.3 meters per second, also east. So I'm going to keep both of these positive. This is negative, and we're looking for displacement. So delta x is my unknown. Vi is 24.5. Vf is 18.3. A is negative 4.2. So let's see. The equation then has to be v final squared equals v initial squared plus 2a delta x. So v final is 18.3 meters per second. Square that guy. V initial, 24.5 meters per second. Squared plus 2 times negative 4.2 meters per second squared times delta x. So 18.3 squared. We get 334.89. 24.5 squared is 600.25. And then 2 times negative 4.2 is minus 8.4 times delta x. I'm trying to get this delta x by itself, so I'm going to move the 600 by subtracting it from both sides. So we get 334 minus 600.25. So that's going to be negative 265.36 equals negative 8.4 delta x. Divide both sides by negative 8.4. And we get For delta x, we get positive 31.59. So we're going to say 31.6 meters. And for this, because it's positive, which makes sense, I'm decreasing in speed because of my acceleration, but that means I'm going east. So the direction is east. An ice skater moving at 2 meters per second begins a constant forward acceleration for 3.5 seconds. So we have the ice skater, la-di-da-di-da. So she's skating. Her initial velocity is 2 meters per second. Her acceleration, it says constant forward, so we're going to assume she's moving in the same direction. This is 0.4 meters per second squared, and then we have the time. So time is 3.5 seconds. Acceleration's positive 0.4 meters per second squared. Initial velocity is 2 meters per second, and we're looking for delta x. So we don't have v final in here, so we're going to use delta x equals v initial t plus 1/2 at squared. So delta x equals v initial is 2 meters per second times 3.5 seconds plus 1/2. The acceleration is 0.4 meters per second squared, and then t is 3.5 seconds. Quantity squared, make sure when you type this in that you square that. So we have 2 times 3.5 plus 1/2 here is 0.5 times 0.4 times 3.5 quantity squared. So we can plug all that in, and so then I get 9.45. I'm going meters because it's displacement, and I'm going forward. So I'll just say forward here.